Hello, welcome to Get2, and in today's video we are going to solve top 2 quadrilateral complex questions. So in this video we're not going to only solve quadrilateral questions, they are going to be complex, so we're going to solve quadrilateral complex questions. So we're going to see how to solve them, and we're going to learn the questions. You can also use the questions by changing them to another and try out by yourself. So let's start. The first one is a complex trapezoid. So when we're going to solve a complex trapezoid, firstly, let's see the question we're going to solve. The question says, calculate the area of a trapezoid where the lengths of the bases are 12 cm and 8 cm and the non-parallel sides, which means they are legs, because as we know, in a trapezium or trapezoid, the non-parallel sides are known as legs. They are 7 cm each, which states that we are dealing with an isosceles trapezoid, and the height is not given, so find the height of the trapezoid. That's the question we're going to solve. So let's imagine this trapezoid. I think the trapezoid we're searching for will look like this. So right here we can see these two are the bases, which are also the parallel sides, and these non-parallel sides, also known as the legs, are given, which are both 7 cm, and the parallel sides, which are the bases, are 8 cm and 12 cm each. This is isosceles trapezoid because we have the legs common, which says that it's isosceles trapezoid, and the height, which is found from one base to another base, is not given, so the height is unknown. So we're going to try to solve or find the value for the height. So firstly, we're going to clarify into steps. Step 1, or the solution, is to find the height. We use a formula of area of trapezoid and the Pythagorean theory. If you guys don't understand what the Pythagorean theory is, we're gonna just ask us in the comment and we can explain it in another video. So for you, it's just an easy equation we're going to use right now. So to find the height, firstly, let's try finding the height using the formula of the area. The area calculation of a trapezoid. For trapezoid with base 1 and base 2 and non-parallel sides are known as A and B, the height can be calculated using an area formula. This is the area formula for a trapezoid, which says 1/2 multiplied by, in a bracket, B1, which means base 1, plus base 2, then multiplied by H, which means height. So when we simplify it, we can easily say base 1 plus base 2 over 2 multiplied by height. So this is the area calculation formula for a trapezoid. So now, since we don't have the area directly, we use the trapezoid height formula involving the Pythagorean theorem for the isosceles trapezoid. The height can be calculated using, so we don't know exactly what is the height is, so we can't calculate it using the area formula. So we are going to use the Pythagorean height formula, which is this. This is the Pythagorean height formula for a trapezoid. So as we can see here, it says height, or H, is equals to, we have a radical, then A square. As I already told you, the legs are called A and B, so A square, which means one of the legs, minus, in a bracket, there's another bracket that says B1 minus B2, which means base 1 minus base 2. We close our bracket, and it tells us the answer in here will be squared. Then we add A square minus B square over, this over works for all of them, and it says 2 into base 1 minus base 2. Then all of this result will be squared by 2. So this is the formula of Pythagorean for finding the height of a trapezoid. Now we're going to use this formula to calculate the height. Here, B1, which means base 1, is 12 cm. We know that already. In the B2, which means base 2, is 8 cm. A, one of the legs, is 7 cm, and so is B. First, find the lengths of the segment connecting the mid-segment of the non-parallel sides, which means that when we're going to search for the mid-segment, or the point that's going to connect the mid one with the non-parallel sides. So the mid-segment is equals to B1 plus B2 over 2. This is a formula we can use anytime when we're searching for the mid-segment. So we know that b1 or base 1 is 12 and b2 or base 2 is 8 centimeters, suppose, divided by 2 we have here. So 12 and 8 gives us 20. 20 divided by 2 gives us 10, so it's 10 centimeter. Now we know that the mid segment is 10 centimeter. We'll move on to our next step. Next, calculate. We're going to nextly calculate h square, which means h square is equals to a square minus b in x square minus in the bracket of b minus b2, close the bracket, squared, and we'll have divided by 2. This 2 only works for the ones in the bracket, which are b1 and b2, which means base 1 and base 2. So h squared is equals to, we already stated that a is equals to 7, so a squared, which means 7 square, minus, we have a bracket that says b1, which is substituted by 12, minus b2 will be 8, then it will be divided by 2 and squared by 2. So h square, 7 square means that 49. And right here we have 12 minus 8, which is 4. 4 divided by 2 gives us 2, and 2 will be squared 2. Then h square gives 49 minus 4, because 2 square gives us 4, which is equals to 45. So h is equals to, for leaving the h, we have a square here, so I'm going to put this one in radical so I can disqualify the square. So h is equals to 45, a radical of 45, which means h is equals to 5 radical 3 centimeter, which is approximately equal with 6.71 centimeter. So when we write it in a formal way, we can say answer, or the final answer is the height of the trapezoid is 5 radical 3 centimeter, which is approximately 6.71 centimeter. So this is the solution for this first complex trapezoid question. Now let's solve our second and last question, which is going to be a complex kite. It's going to be a complex kite, and it is going to be the last question for today. So let's see what is the problem or the question here. It says here, a kite has a diagonals of length 24 centimeter and 32 centimeter. So since we know that kites have two diagonals, one of them is 24 and the other one is 32. The shorter diagonal, which is clearly 24 centimeter, bisects the longer diagonal, or the longer one, at right angle, which means that they're going to form a right angle when they're being bisected. Calculates the area and the lengths of the sides. So let's try to imagine what this kite will look like. I think it will look like this. So we have here a kite. One of them is 30 centimeter, which is a longer diagonal, and the other one here has 24 centimeters, the shorter one. And as you can see here, there is a right angle formed. So we're asked to find the area of the kite and the sides, which are this, and then there is this side. We don't know. As we know in kites, the consecutive angles are equal, which means that these sides, the adjacent sides, are equal. So these two would be equal and these two would be equal. So finding one means finding the other one. So now let's solve this question. Solutions. Area calculation. First, we're going to calculate the area. To calculate the area, kites given by area is equals to 1/2 multiplied by diagonal 1 multiplied by diagonal 2, which means when we clarify it, diagonal 1 multiplied by diagonal 2 over 2. Since we know what is the first diagonal in the second, we can easily calculate the area, where diagonal 1 and diagonal 2 are lengths of the diagonals. Then we can calculate it, because we can see here the given is diagonal 1 is 24 centimeter and diagonal 2 is 32 centimeter. You can also name diagonal 1 32, diagonal 2 24. That doesn't have a difference actually. So area is equals to 1/2 multiplied by 24 multiplied by 32 centimeter. So area is equals to 24 centimeter into centimeter, so this will be a centimeter square. Then when we multiply these two and divided by 2, it will be 384 centimeter square. Now we have solved one part of the equation, which is to find the area. Now the last part is to find the lengths of all sides. So to calculate that, which is a side length calculation, to find the side lengths or the side, use the Pythagorean theorem in one of the right triangles formed by the diagonals. We know that the diagonals form a right angle when they bisect because one of them is straight this way and the other one is straight that way, so they will form a diagonals of a right angle triangle. Okay, to make this easier, let's create an image of it. Okay, so when we make our image, it will look like this. This is a kite, right? So this kite has 4 parts. These diagonals form 4 right angle triangles, one here, the second one here, then the third one here, then fourth one here. So let's just pick out one of them only. So this is the only one. It is just a part of the kite, just one part of it. So this is a right angle triangle. So now we're going to use the Pythagorean theorem to find the side, which is this side, using the right angle triangle we got from the diagonals of the kite. Each half of the diagonals will be half of a diagonal of which is diagonal 1 minus half of a diagonal of diagonal 1 will be equals with 12 centimeter. And the same works for the second one. So when we clarify it, it's just simply diagonal 1 is 24, so I'm going to divide 24 by 2, which will be 12, and diagonal 2 is 32, so 32 half, which means dividing it by 2, will be 16 centimeter. So now the half here, which is this one, will be 12 and this one will be 16 centimeter. Now the side length is the hypotenuse of the right angle triangle with legs 12 centimeter and 16 centimeter. So since this is our right angle triangle, this will be the hypotenuse. So to find this hypotenuse, we have the legs, the two legs, which are 12 centimeter and 16 centimeter. So we're going to use the Pythagorean theorem. So side is equal to 12 plus 16, and there will be a radical for it. So they will be both squared firstly. So side is equal to 144, because 12 squared gives us 144 plus 16 squared, which gives us 256, and they will be joining a radical. So the side is equals to 400 in a radical. 144 plus 256 gives us 400, and it will be put in a radical. So the side will be 20, and then we're going to bring our centimeter here, so it will be 20 centimeter. So this part, which is the hypotenuse, will be 20 centimeter. That means we have found the length of the side. So the final answer is the side is going to be 20 centimeter. This is how we solve a complex kites, and in this video we have solved 2 toughest complex quadrilateral questions. The first one was the complex trapezoid and the second one was complex kite. And ask us any question you want us to solve in the future. Send a comment, like and subscribe, and hit that notification bell to review on new videos uploaded from our channel. See you in the next times. See you then.